Alright, so I'm actually going to kick this off with a video so that we can understand the basic way to look through the textbook. Most students don't know how to look at the textbook and learn from it, so I'm going to walk you through a lot of these examples in step-by-step process. First thing I want to draw your attention to is that this is the 1.1 solving simple equations section. We have an essential question here to start it off, and this is an exploration. Generally what we'll do is we'll do these explorations if we're going to do them together in class. So looking at these two things, we're going to skip over those for right now, and we're actually going to focus on something that's going to be applying the math skill that we're learning for the day. So I'm going to skip forward to the next page. Now on this page again, it's showing you what you're going to learn. It's showing you the three skills that we should have after this lesson is we should be able to solve a linear system using addition or subtraction, solving a linear equation using multiplication and division, and then use a linear equation to solve real life problems. So really, you guys, what we're doing here in this first video is solving a one-step equation. You can look over these definitions and read through them on your own. I'm going to spend this time in the video applying the math skills that we need. So I'm actually going to skip down here to the examples. You'll notice in mine that it's whited out and it's not whited out in your textbook. So when you go to your textbook, you're actually going to see all this stuff worked out. This should be stuff that's not really new to you if you're in Algebra 1. This is the basic stuff that we did last year in pre-algebra, but I'm going to go ahead and go into it here a little bit. So I need to zoom in and make sure that I have room to write. You guys will be able to see this as well when you guys will probably do most of your work on scratch paper, but again, the first step, and you'll see it in your textbook, it'll say off to the side over here, it'll say write out the equation. So mine's written out. I don't need to do that step. You guys will need to write out x minus 3 equals negative 5. Our step to isolate x would be to add 3 to both sides, and it should say that in your textbook if you're going back and forth. Then after we add 3 to both sides, all we're left with on the left-hand side is x because the 3's cancel out, and we get x is equal to negative 5 and positive 3. When we are adding and subtracting integers, we look at the signs. If the signs are different, we subtract. So negative 5 and positive 3, we're going to subtract 5 minus 3 and get 2. The bigger number is negative, so we keep that negative sign. That's the rules of addition and subtraction, so we have to keep those in mind. Moving on to example B. Again, it's no different with decimals. We look at what we have. We want to isolate this variable right here, y. So if I want to isolate that variable, what I need to do is I need to subtract 2.8 from both sides. When I subtract 2.8 from both sides, again, I notice and I look at my rules of addition and subtraction. My bigger number is actually on bottom. So now what I'm going to do is I'm going to rewrite this so that my bigger number is actually on top, and I'm not going to put the negative sign with it. I know that I have different signs. The 0.9 is positive, the 2.8 is negative. I need to subtract because the signs are different. And again, I'm going to show this borrowing because some of us struggle at it. We cannot do 8 minus 9. And again, the decimals are lined up. We have to make sure we do that, but I can't do 8 minus 9, so what I have to do is borrow. That becomes a 1. Now this is 18. So now I have 18 minus 9, and I get 9. And then I have my decimal place, and I have a 1. So we go back and look at what sign our answer should be. The bigger number was negative, so I get negative 1.9 for my answer, and that is equal to y. It doesn't matter which side I put y on. Now what we have is a monitoring progress. So what we can do now is look at these next three problems. They're very similar to the ones that we just did. And what you guys are going to do is you're going to pause for a second here and you're going to take time to try these. And what I'm going to do is I'm going to put the answers. So what you need to do right now is pause and do 1 through 3 right here. And I'll zoom out so you can see them and just do them on your scratch paper here. Okay, so now if you guys have taken a second, you'll see that I did the work here, and you guys should always show your work. That's really important in any math class. It helps me see what steps you took to get to your answer. You'll see in this first one, number 1, the 3's cancel when you subtract from both sides. Our answers, or excuse me, our numbers on the right-hand side are both negative. We have a negative 7 and a negative 3. The rule is if the numbers have the same sign, you add it up and keep the sign. So I get my answer, n is equal to negative 10. The next one, we have negative 1/3. We add it to cancel, and then I have a negative 2/3 and a positive 1/3. So again, they're different signs. I subtract. The denominators always stay the same when we add and subtract fractions. If you forget that, I'm sure there's a practice sheet we can work on just to make sure that we are doing that correctly. But we have 2 minus 1 is 1. We keep the sign of the bigger number, which is 2. Last one here, the 3.9 cancels when we subtract it from both sides. You'll notice on the left-hand side that both numbers are the same sign. So I added them up and I kept the negative sign. So that's how you do that first set. One other thing that I forgot to draw your attention to in the book is that they do a great job of showing you how to check your answer. So you'll notice here that in your book it'll say negative 2 minus 3 is equal to negative 5, and they have a little question mark there. And then they go ahead and do the math, and then they say negative 5 is equal to negative 5, and then they say check. That does check out. So make sure that if you guys are uncertain, you're plugging those back in and seeing if you're doing them right. Again, just going over how to utilize your textbook. Look over those definitions when it says core concept at the top, and there's a little box. You need to look those over. Really what this is saying is here's how you unhook things using multiplication or division, so you need to understand that. Example 2 gives us 3 different problems. I'll go ahead and zoom in here so I can show my work nice and neatly for you guys, and I expect the same of you. Again, off to the right it says to write the equation. I have room, so I don't need to rewrite mine. How we unhook division, I have a lot of students that look at this problem and they see a fraction. It's not a fraction, it's a number hooked to a variable by division. So we unhook it by multiplying both sides. When we multiply both sides, we cross it off on the left side. On the right side, you'll notice negative 3 times negative 5. We need to understand that a negative times a negative gives us a positive answer, and we get n equals 15. When you go over to the right, you'll see that they've checked their work and they put 15 in, and they take 15 divided by negative 5, and it checks out and gives us negative 3 for an answer. A lot of times students will forget the fact that pi is a number. It's not just a symbol. So we need to understand, again, that's hooked by multiplication. We can unhook it by using division. When we unhook it using division, it cancels out here and it cancels out here. So what we end up with is just x is equal to negative 2. That's something that you're going to start running into a lot more in things like geometry and trig and algebra 2, so you need to have that understanding. Lastly, here we have a decimal problem. Again, decimal division is a little bit more complicated, so we need to make sure that we still understand how it's hooked. It's hooked by multiplication, so we need to divide. When we divide this, many of you are probably going to refer to your calculator. Not really necessary. When we divide, we never want to divide by a decimal, so we're going to do some side work here. What we want to do is we want to take this and we want to make the number that we're dividing by a whole number. However many times we shift it in the denominator, that's how many times we want to shift it in the numerator also. So what we have here essentially is 52 divided by 13. Let me get that fixed there. And if we take 52 divided by 13, we get 4. 4 times 13 is 52 with no remainder. If we would have had a remainder, it would have fallen after the 4, but it does not, so we can just leave our answer as 4. So z is equal to 4. Okay, so again, we have some practice problems here at the bottom. I'm not going to spend as much time talking through all of them. You pause the video, take a second to try these next 3 on your own. I'll zoom out here so you can see them. Once you can see them well, pause, do them, and then we'll go over them together. Okay, so go ahead and pause this if you need to take more time to look at it. The only one I'm really going to talk through is number 6 because students struggle to remember how to do that. So again, number 6, you'll look, we need to divide by 0.05. You'll see these little red marks. That means that I needed to shift this 2 times to make it a whole number. That means I need to do it to my numerator as well. So I kind of missed here. It needs to be 140 divided by 5, and you guys should be able to do long division. Again, if that's something that you need help with or caught up with, you need to come talk to me. Lastly, here we have this solving real life problems. You guys last year in the old textbooks, this little box right here up at the top of the page used to be an entire lesson. you guys should know how to put together a problem and solve a story problem. So I'm just going to talk through the process of it here real quick, and actually I'm just going to look at number 4, example number 4, but odds are you guys will be able to figure out how to put it together, because whatever the story problem is, they're probably going to give you a formula, and you're going to be able to look at the problem and give either a distance, a rate, or a time. Or if here before I finish up with this video, again, it gives you how to set up the problem as you solve it. So this right here, this whole thing right here is your problem. This is not really a story problem. It's 3 sentences long. So we should be able to figure out how to solve this problem with it being so short. Again, in your textbook, they're probably going to give you something like this to just plug in numbers. So we will still cover things like this in class. We will have story problems on quizzes. It won't be hard though. It'll be something just like this. So make sure that you don't just skip those, especially when it comes to homework and quizzes and tests and state assessments. These problems are not as hard as they look sometimes, and we just need to take a second and read through it and make sure we understand the problem. So again, we'll be discussing this pattern up at the top here very frequently of how to put together and solve a story problem. As far as that goes, you guys, what I want you to do now, I'm not going to have you do an assignment over this right now. I am going to have you do an assignment over this right now, but I'm not going to go to those pages in your textbook. What I want you to do is go back to Big Ideas Math and sign in and look and see what your assignment is for the day. Once you do that, then you should be able to figure out how to do the problems. Your assignment's going to be short today, and then tomorrow what we'll do is we'll see how this process works and see if we can't make this something that we do on a regular basis.